Hi everyone, welcome back. Let's write some more Leetcode today. Today we are solving maximum ascending subarray sum. I will go over two ways to solve this problem, but we'll only go over the coding for the optimal solution. If you're only interested in the optimal solution, then feel free to skip to the timestamp. So the problem states that we are given an array of positive integer nums, and we want to return the maximum possible sum of an ascending subarray that is in nums. And a subarray is defined as a contiguous sequence of numbers in the array. And basically a subarray is considered ascending if it is increasing from one index to the index afterwards. And we also want to notice that a subarray of size 1 is still considered ascending. So if we look at these examples, the largest subarray in example 1 would be in the end where 5 increased to 10 increased to 50, and we add that up, it's 65. For this example, the entire array is ascending, so we add the sum, which is 150. And for the last example, we see that the largest ascending subarray happens at the end at 10, 11, and 12, and if we add that up, it equals to 33. So how can we solve this problem? One way that we can solve this problem is we can just calculate the longest ascending subarray from each index. So at each index, we will keep adding to the right until it is no longer an increasing value from the current index. So if we look at index 0, the sum is 60. At index 1, the sum is 50. Index 2, sum is 30. At index 3, the sum is 65. At index 4, the sum is 60. And at the last index, the sum is 50. And obviously, the maximum value that we can have is 65, so that will be our result. The time complexity of this approach will be O of n squared, where n is the number of elements in the array, because we will have to look at each index. And at each index, we can keep moving to the right n times. So it would be a nested for loop, and it can take n squared time. So there's actually a more efficient way to solve this problem, and I'll go over that one right now. A more efficient way to solve this problem is we can look at each index, and at each index, we can update the current sum. However, if we get to an index where it breaks the streak of an ascending subarray, then we need to reset the current sum to the value at the current index. So let's go over this example. We'll start off the current value and the result as the value at the first index. So we start here at the first index, update the current value and the result, which is 10. But now we move on. It's ascending, so we add 20 to the current, so which is 30. And then we also update the result, which is also 30. Then we move on. It's still ascending, so we update the current to 60. And then the result is also 60. And then now we move on. It's no longer ascending, so we need to reset the current to the value at the current index, which is 5. The current max result is still 60. Then we move over, add 10 to current because it's still ascending, so 15. Don't need to update result because 60 is still the maximum subarray that we have. And we get to the last value, which is 50, so add 50 to 15, which is 65. And then we update result, so the result is 65. And the time complexity of this approach would be O of n, where n is the number of elements in the array because we need to look through each index once. And the space complexity would be O of 1 because we are not using any extra space. So now let's get to the coding part. So if we set the result and current value to both nums of 0, so the value at the first index. Now we write the for loop for I in range 1 to the length of nums. And if nums of I is greater than nums of I minus 1, so the previous value, then we will add nums of I to the current value. If that's not the case, then we reset the current value to the nums value at the current index. And we will update the result after each iteration, so the max of result and current, and we just return the result. See if it works. Okay, perfect. Hope this was helpful. Thank you all for watching. And if you have any other questions or comments, feel free to leave it down in the comment section. And I hope to see you all again soon.